the determinant, if you are the determinant value, if you are getting 0, then we will tell that the given two straight lines are intersecting are coplanar. Okay, so to find the plane containing them, we need another equation. So in the question they will ask one more equation to find. To find the equation, we'll find that is the determinant of x2 minus x1, x minus x1, y minus y1, z minus z1, l1 m1 n1, l2 m2 n2. Okay, to find the equation. And yesterday we have seen that two straight lines, if they are in the symmetrical form, easily we can find the condition of coplanarity or the condition of intersection, and we can find easily the equation of the plane also. And the next one, to find the point of intersection, I have told the first method. Okay, that is, you have to do the cross multiplication of the line equations, then you will get two equations of plane for the first line, and for the second line you will get the two planes, and if you solve those two planes you will get x, y, z values. So those x, y, z values are called as a point of intersection. Okay, we have seen the first method, and another method is there in which means one line will be given as a symmetrical form and another line it will be given in the unsymmetrical form. Okay, if you see the problems 125 page number MEQ questions. So we have seen the sixth problem. So after that, seventh problem, eighth, almost these are all same. Eighth problem, you have one given line equation is in symmetrical form and another line equation is in the unsymmetrical form. Okay, so one thing is whatever the second line equation is there, if you convert that into symmetrical form, because already you know the concept of conversion. So if you convert the unsymmetrical one into symmetrical one, you will get two line equations in symmetrical form. Then you can do whatever the procedure yesterday I have told, that procedure you can follow. Okay, so if you feel that is difficult, it means the thing is it will be the lengthy process, because first you have to convert them. After doing the conversion, just you can substitute the values in the formulas. Okay, so that is one method. So another method is by keeping like that only unsymmetrical form, you can find the point of intersection and you can show that they are intersecting each other, and even equation also we can find. Okay, you can do the problems in 3D any method. Okay, but the thing is only whatever the at last solution you are getting, that it should be correct one. Okay, so now we'll see one symmetrical and unsymmetrical line equation, intersection and point of intersection. Show that the lines x plus 4 by 3 equals to y plus 6 by 5 equals to z minus 1 by minus 2. Okay, if you see this question in your textbook, okay, it is the 10th problem. So if you see in the 10th problem, last whatever the z is there, z minus 1 by 2, you have the minus sign is there. Actually in between of this divided sign is there, no, there negative is there. So here either you can take that negative value numerator or denominator. Okay, so here for convenience I am taking the negative value in the denominator. So here the value of this one will be negative. Okay, and another line is 3x minus 2y plus z plus y equals to 0, comma 2x plus 3y plus 4z minus 4 equals to 0. Okay, so these are the two line equations. This is the symmetrical form and this is the unsymmetrical form. So in the solution you write again these two equations. So here I am in the question only I am putting this as equation 1 and the equation 2. Okay, so here you write the given lines are, you write this one and you take it as equation 1, and then you write this one and you take it as equation 2. Okay, so after that, so here the procedure to find the with unsymmetrical and symmetrical is that, So whatever this unsymmetrical is there, you join these two plane equations with the help of the lambda. Okay. So that means this plane equation plus lambda of this one. So then you take out x, y, z quotients common. Then you in place of x, y, z, you substitute these direction cosines or direction ratios. Okay. So when you multiply with 3, 5, minus 2, to those whatever the equation combination of two planes equation is there, then we can find the lambda value. Okay. So after getting the lambda value, if you substitute in the equation, you will get one means combination of these two planes, you will get one more equation. So that equation is the third equation. So if in the third equation, whatever the points are there, this one 4, 6, this is -4, -6 and +1. When you substitute in that equation, if you are getting the value as 0, okay, then we'll tell that the given two lines are coplanar to each other or intersection to each other. Okay, this is the concept of this one. There in the formula we are substituting x2 minus x1, y2 minus y1, z2 minus z1. Okay, L1 m1 n1, L2 m2 n2. Here through the unsymmetrical form, with the help of the points x1, y1, z1, we are showing that the given two lines are intersection or coplanar to each other. Okay, after showing that it is an intersection, then we have to find the point of intersection. Okay, to find the point of intersection, you have to take here the coefficients of any one plane, either this plane or this plane. You take the coefficients of x, y, z, and if you take here, if you equate it to r, same procedure. We have done one problem, example problem, how to find the point of intersection. Through that procedure, you have to find the point of intersection. Okay, so whatever the equation, after substituting x1, y1, z values, you are getting 0. That equation is only called as the equation of the plane in that which lies in the given two lines. Okay, so this is a method of finding when unsymmetrical and symmetrical. Okay, so the general equation of any plane, the general equation of any plane through the line is, okay, it is 3x minus 2y plus z plus 5 plus lambda into 2x plus 3y plus 4z minus 4 equals to 0. You put it as equation 3. Okay. Now you take, means you are writing the like terms on both sides. So if you take here x common, you will get 3 plus 2 lambda. Here 2 lambda is there, plus y into the quotient of y is -2 plus 3 lambda. After that here plus z into the quotient of z is 1 plus 4 lambda. After that you take the constant terms, that is 5 minus 4 lambda equals to 0. Okay, so after doing the simplification, you are getting this one. So now you are taking that whatever the here direction ratios are there in place of x, y, z. That means you have the formula, no, when they are perpendicular to each other, a into a1 plus b into b1 plus c into c1 equals to 0. Okay, so you write here this plane 3 this plane 3 will be parallel to the line 1 if, so here the quotients are 3, that is 3 into 3 plus 2 lambda. After that 5 plus 5 into -2 plus 3 lambda. Z is -2, that is -2 into 1 plus 4 lambda. Here constant term will be not there. Why? Because perpendicularity is only AA1 plus BB1 plus CC1 equals to 0. Okay, through that only we are taking this one. So now you simplify this one, you will get the lambda value. So 3 3s are 9, 9 plus 2, 18 lambda, minus 10 plus 15 lambda, minus 2 minus 8 lambda equals to 0. First you take the lambda values. Here 18 is there. here minus 8. So you will get 10 lambda. 10 lambda plus 15 means 25 lambda you will get. Okay, 3. It is 6 lambda, no? 3 to the 6 lambda. So 6 means minus 2 plus the 15 means it is 13 lambda. Next we have 9. This is minus 1 minus. So you will get minus 3 equals to 0. So what is lambda value? Implies lambda is equals to 3 by 13. Okay. So whatever the lambda value you are getting here, you substitute in the equation 3. So next substitute lambda in equation 3. Then we get. Okay. So this is the, if you have both in some cases you will have both the even unsymmetrical form also, that you will have in shortest line segment. Okay, there also we'll use the same procedure. Here whenever it is symmetrical and unsymmetrical, so if you feel this method it is, if it is any difficulty is there means, then you convert this whatever the unsymmetrical is there, this is the unsymmetrical one, no? Unsymmetrical one into symmetrical form, that is by taking z is equals to 0, then you will get x, y, z values. To find the a, b, c values, we'll write them as 3a minus 2b plus c equals to 0, 2a plus 3b plus 4c equals to 0. When you do the cross multiplication, you will get a, b, c values. Okay. And if you substitute in the formula, that is x minus x1 by a equals to y minus y1 by b equals to z minus z1 by c. When you substitute there, you will get the line equation in the symmetrical form. Then directly in the formulas, if you substitute, you will get the answer. Okay. So this is one procedure, and that is 3 procedures are there. Okay. So first one is if you have both the symmetrical form. Second one is you can convert the unsymmetrical into symmetrical one. Then you can find the solution. This is the third one. So for solving the problems which is convenient to do, that you follow the procedure. Okay. So after this, okay, after substituting the lambda in equation 3, you will get one equation. So 3x minus 2y plus z plus 5. What we have? 3 by 13 of 2x plus 3y 4z minus 4 equals to 0. Okay. Now we do the cross multiplication here. 13 into this one and plus 3 into that one. So 13 here, 13 3s are 39 minus 26y plus 13z plus 65. Here 3 2s are 6x plus 3 3s are 9y. 12z minus 12 equals to 0. Okay. So now you add whatever the like terms are there. 39 plus 6 means 45x minus 26y is there plus 9y. How much you will get that one? That is 17y and 13z plus this is 25z. So 65 minus 12 means you will get it as 53. So plus 53 equals to 0. Okay. So this is the line of the equation. So we are getting through adding. This is the general equation we are getting through adding. That is the lambda in between of the two given planes. Okay. So this is only the equation which is containing in the two given lines. Okay. So last we will find now that is determinant of x minus x1, y minus y1, z minus z1, L1, M1, N1. In L2, M2, N2, if it is equals to 0, and if you find the determinant, you will get the equation of the plane. So whatever that plane is there, this is only that plane. Okay. So no need of again finding that one. But the thing is, whatever the plane you are getting this one, it should satisfy the point. That means if you substitute here x, y, z values, you have to equate it to 0. So after this plane passes through So which point here? So first equation, first is symmetrical form is there. No, in that x minus x1, y minus y1, z minus z1. So what are x1, y1, z1 values? You see. So plane passes through. We have -4, -6, and z value is 1. Okay. So the plane passes through this point. So that is, you substitute this one, that is 45 into 4 minus 4, okay, minus 17 into minus 6 plus 25 into 1 plus 53 equals to 0. So 45 into minus 4 is minus 180. This is plus 102 plus 25 plus 53. Okay. So this value is, this is 180, and if you add this one, you will get as plus 180. So minus 180 plus 180. So it is equals to 0. Okay. So whatever the equation you are getting, when you add the two planes with the help of the lambda, that equation is called as a equation of the plane. When it is satisfying that, when you substitute this point in this equation, you have to get the value as 0. Okay. When you will get that value as 0, then we'll say that the two given line equations are intersecting each other or coplanar to each other. Okay. So here we can write, thus the given two lines are, so in your question, what is asked, coplanar or intersection? 10th one, no? So coplanar he has asked. So thus the two given lines are coplanar. Okay. So this is the, if we got one equation and we have shown that it is, they are coplanar. Now the thing is, we have to find the point of intersection. Okay. So for finding the point of intersection, you write coplanar and equation of plane containing them, given two lines 1 and 2 is, okay. So you write this one, that is 45x minus 17y plus 25z plus 53 equals to 0. Okay, half part we have completed. Now the thing is, we have to find the point of intersection. So for finding the point of intersection, you take the line equation 1. So in that is, so what is the line equation? X plus 4 by 3 equals to y plus 6 by minus 5 equals to z minus 1 by 2 equals to r. Okay, you're taking it. So you know the procedure how to find the point of intersection. So we are taking this. So any point on line 1 is, that is, you do the cross multiplication of, when you do the cross multiplication, what you will get? X as 3r minus 4 minus 5r minus 6 minus 2r plus 1. Okay, this is the point. And you know that if you substitute this, whatever the point is there, this point means it is the x value, this is the y value, and this is the z value. If you substitute this point in any one of the unsymmetrical equations, so we have two unsymmetrical equations, no? If you substitute in either first plane equation or in the second plane equation, you will get the same r value. Okay, don't think that if you substitute in one, you will get another one value, and in the second one you will get the another value. Okay, so if you substitute the same xyz value in first plane or in second plane, you will get the same r value. So when you substitute r in this one, you will get the point of intersection. Okay. So after that, if it lies on first plane of equation 2, then we get. So try to write all the steps whatever you have in your solving the problems. Okay, don't do direct problem. In between of the problem, you write the steps whatever are there. Okay, so then we get. So what was the first plane equation? It is 3x minus 2y plus z plus 5 equals to 0. Okay, this is the first plane equation. So 3 into this one, 3r minus 4 minus 2 into y, 5r minus 6. After that, plus minus 2r plus 1 and plus 5 equals to 0. Okay, now you multiply this and simplify. 3 is a 9r minus 12 minus 10r plus 12 minus 2r plus 1 plus 5 equals to 0. So minus 3r, next minus 12 and plus 12 both will get cancelled, it is plus 6. So implies minus 3r equals to minus 6, both minus will get cancelled, implies r is equals to 2. Okay, so substitute this r in. So if you want, you can put here fifth equation and 5. Then we get, so what will get that one? That is 3 into 2 minus 4, 5 into 2 minus 6, minus 2 into 2 plus 1. So this is 3 to the 6, 6 minus 4 is 2. And here 5 to the 10, 10 minus 6 is 4. And this is minus 2 to the 4 plus 1. It is minus 4 plus 1 is minus 3. Okay, the point of intersection is 2, 4, minus 3. So we can write E is the point of intersection. Okay, so this is the procedure to find when one symmetrical and another one unsymmetrical is given. Okay, so you have the problems in your textbook. Sixth problem I have told. After that you have 7, 8, 9th is the same one. Show that the line intersects the line. Find the point of the intersection. Okay, so 9th, 10th I have told. So 11th one, angle between the lines we have. And the 12th one is find the equation of the line that intersects the lines and passes through the point. Okay, this I will tell this. And 13th one, same parallel to so as to intersect. So almost in this, whatever the MEQ questions are there, 1 to 12 questions are important one, means 10 marks question you will get from this one only. So now we'll see the other problem, that is a parallel is there in, if you'll see 113 page number, you have the concept of line intersecting two given lines. Okay, so one line intersecting the other two lines. So that is the third, which problem means 12th problem. Okay, find the equations of the line that intersect the lines. Find the equations of line that intersects the lines 2x plus y minus 4 equals to 0 equals to y plus 2z. Okay, here in your textbook you correct this one. 12th question is there, no? So the line equation 2x plus y minus 4 equals to 0 equals to y plus z is there. Okay. When you solve this one with the whatever the procedure is there for this problem, so you will not get the lambda 1 value. Okay. So here 2z should be there, then only we'll get the lambda value. Okay, try to correct that one. Here you write 2z. Okay. Comma x plus 3z equals to 4 comma 2x plus 5z equals to 8 and passes through the point 2 comma minus 1 comma 1. Okay, so first you write the given line equations are so we have 2x plus so another one is 2x plus yz minus 8 equals to 0 equals to okay, first you have this one x plus 3z minus 4 equals to 0 equals to 2x plus 5z minus 8. Okay, you write like this in the line equations. Both you combine the plane equations. Here they are separate, you can join them. Okay, so after that you write the general equations of the general equations of the, we can put it as 1 and 2 equations of the line intersecting the two given lines, the two given lines are okay. So this you join these two plane equations with lambda 1 and these two plane equations with lambda 2. Then if you find the lambda 1 and lambda 2 and if you substitute in that one, then you will get the both the line equations. So what is the question? Find the equations of the line. Equations means two equations we have to get. Okay, so find the equations of the line that intersects the lines. So you have to get the two equations which are intersecting the other two equations. Okay, so other two equations of the lines is this is one line equation and this is another line equation. So the procedure for solving this problem is you have to combine the two plane equations with the help of lambda 1 and with the help of lambda 2 for the second plane equations. And if you substitute this point in that one, okay, whatever the equation you are getting, if in that equation, if you why because and passes through the point he is telling. So if you substitute x y z values as 2 minus 1 and 1, you will get the value of lambda 1 and also lambda 2. So when you substitute the lambda 1 and lambda 2 and if you do the simplification, you will get the equation of two lines. Okay, that is the procedure here. So 2x plus y minus 4 plus lambda 1 into y plus 2z equals to 0. Okay, so next one is x plus 3z minus 4 plus lambda 2 2x plus 5 minus 8 equals to 0. So you can take this as 3 and this is our fourth equation. Okay, here if you want we can simplify this one, that is you take here only one x is there but yr2 is there and only single z is there, just you simplify that one. So you can write here that is 2x plus y into 1 plus lambda 1. Okay, so plus 2 lambda 1 z, if you multiply this minus 4 equals to 0. First one. Next one is x is there here. So x, if you take common, 1 plus 2 lambda 2. Okay. Next, y value is not there. Here 5z, no? 2x plus, this is the 5z, okay. So here also it is 5z minus 8. So what we have here, plus z into 3 plus 5 lambda 2. Okay. And the constant values are minus 4, here minus 8 lambda. Okay. So this is equals to 0. So these, for these two equations, so 3 and 4, no, you can take here 5 and 6. Okay. Now take whatever the point given in the question, it passes through 5 and 6. Okay. So therefore the line passing through the point if you want, you write like this. The two passes through the point. What is the point here? 2 minus 1. Then we get, so now substitute here, that is 2 into 2. And here minus 1 into 1 plus lambda 1 plus 2 into what is the z value? Z value is 1 minus 4 equals to 0. To simplify this one, 2 to the 4 minus 1 minus lambda 1 plus 2 lambda 1 minus 4. So 4 will get cancelled here. Minus lambda 1 and plus 2 lambda 1 means you will get it as plus lambda 1. That is implies minus 1 plus lambda 1 equals to 0. Okay. So you will get the minus 1 equals to minus lambda 1. Both will get cancelled. So lambda 1 is equals to 1. Okay. So in sixth equation, when you substitute, so when you substitute here, what you will get? 1, 2, no? 2 into 1 plus 2 lambda 2. Here y value is not there, so only z. Z is minus 1, 3 plus 5 lambda 2, minus 4 minus 8 lambda 2 equals to 0. So it was 2 plus 4 lambda 2 minus 3 minus 5 lambda 2 minus 8 lambda 2 equals to 0. So minus 4 is there, means minus 7. So you'll get minus 5. Minus 3 minus 5 lambda 2 minus 4 minus 8 lambda. Okay. So negative minus 3 minus 4 means minus 5 you are getting. And here 4 lambda 2 minus 5 lambda 2 means you will get, okay, something somewhere okay. 1 plus lambda 2 we have to get 2 plus 4 lambda 2 plus 3 plus 3 plus 5 lambda 2 minus 4 minus lambda. Here anything we have done mistake. It is minus 1. Okay, z value is 1. No, I have written minus 1. That's why it is wrong. Okay, here plus and plus. Okay, so z value is 1. Y value is minus 1. So if you multiply plus 3 plus 5 lambda minus 4 minus 8 lambda. Now 3 plus 2 is 5. 5 minus 4 means you will get it as 1. And here 5 plus 4, 9. 9 minus 8 means you will get plus lambda 2 equals to 0. Implies lambda 2 equals to minus 1. Okay. So lambda 1 is 1 and lambda 2 is minus 1. So now substitute this lambda 1 and lambda 2 in 3 and 4 equations. Then you will get the equations of lines. Substitute lambda 1 and lambda 2 in 3 and either you can substitute here 5 and 6 or 3 and 4. Anywhere you will get the same equations. Okay. So third equation was 2x plus y minus 4. So what is lambda 1? Lambda 1 is 1. 1 into y plus 2z equals to 0. So if you simplify this, 2x here plus y plus 2z minus 4 equals to 0 implies 2x plus 2y plus 2z minus 4 equals to 0. So if you take 2 common from this, what you'll get? X plus y plus z minus 2 equals to 0. So when you do the simplification of this, it is x plus y plus z. You can put either minus 2 equals to 0 or you take on the right hand side you will get as equals to 2. Okay. So when you substitute in the fourth equation, so in fourth equation, what was the fourth equation? X plus 3z minus 4 minus 1 into 2x plus 5z minus 8 is equals to 0. Okay. So when you simplify this, x plus 3z minus 4 minus 2x minus 5z minus into minus plus 8 is equals to 0. So x minus 2x means minus x, y is not there, plus 3z minus means minus 2x, minus 8 here means plus 4 equals to 0. If we take out minus common here, x plus 2x minus 4 equals to 0 or x plus 2x equals to 4. Okay. Is here. So x plus 2z equals to 4. Okay. So at last you can write the equations of the line that intersect the given lines. The equation of the lines that intersect the given lines are. So what is the first equation we got here? X plus y plus z equals to 2 and x plus 2z equals to 4. Okay. This is the procedure of finding the value whenever the two line equations are there and we have to find the equation of the intersecting two lines. Okay. So try to solve the worked out exercise problems are there in this and also example problems are there and check your progress. So all you have to practice. Why? Because you may get a question from anywhere. Okay. And one more concept you have here, 118 page number, that is finding the image of the line in the plane. Okay. So in the example problem, that is here exercise is there, in that it is given that image of the line, here line equation is given, that line in the plane, and you have the problem, this one same in MEQ it is there, page number 125, you have the second problem is there. Okay. So that whatever MEQ question is there, in that he is asking find the image of the point So here one point is given 1 comma minus 1 comma 5. You have to find the image of the point in the plane equation. So there is a difference between the question you have in 118 page number and also the question you have in 125 page number. Okay. So here is asking the image of the line. Here is asking the image of the point. Okay. So you know, if you'll see the 118 page number, you can understand how to find the image of the line in the plane. Okay. First you are taking the point is there, that is 1 0 minus 2. That means the point in the equation of the line, x minus x1, y minus y1, z minus z1. No. So your x1, y1, z1 values are 1 0 minus 2. So you are taking that as point of the line. Okay. And let q be the image of p in the given plane. So every time whenever you see the point, image of the point, means here you can take any plane like this. Okay. We can call this plane as pi, or else you can write the equation of the given plane, whatever in the given question is there. 2x plus y minus 3z minus 4 equals to 0. So for this one, you will have one point like this. This is the point. Here, instead of the point we have in the question, equation of the line is there. So for the equation of the line, the point is here x1, y1, z1. So P will be here x1, y1, z1. Okay. So this will be the Q. So we have to find here the Q value. Okay. So in some cases, so P here Q, in between of that midpoint also he will ask. So in this problem, he is giving the equation of the line to find the image of the equation of the line on the plane. Okay. So for that, you see the procedure. We have to find here the Q value. So for that, you take the line equation as equals to R. How we'll find the point of intersection? No, same like that only. If you equate it to R, you will get x, y, z values. So the coordinates of any point on this line are, if you do the cross multiplication, you will get the value and the midpoint of PQ. So your P to Q, no. So in this, we are finding the midpoint of this one. So you can take this as R. So to find the midpoint of PQ, R, we have to divide this 2R plus 1 plus whatever the point is there, no, 1 comma 0 comma minus 2. That means, you know, I think so, midpoint is, the formula is x1 plus x2 by 2, y1 plus y2 by 2, comma z1 plus z2 by 2. So this is x1. If you take here x2 comma y2 comma z2, so we'll get this R as a midpoint of these two. No? When you divide this by 2, you will get that one. So here the point, we have P as a point is 1 comma 0 comma minus 2. And when we are equating this line equation equals to R, we got one more point. No, that is, this is 2R plus 1 comma R comma minus 3 minus 2. So this 2R plus 1 divided by 2, if you do, then you will get the value of R. Okay. So if this point lies in the given plane, so when you divide them, you will get one value. If you substitute that value in the plane equation, what is the plane equation? 2x plus y minus 3z minus 4 equals to 0. Then you will get the R value. Okay. So when you get the R value, so you will get x2, y2, z2. Why? Because already P value is there. So we'll get this one, and even R also you'll get. Okay. So that is the procedure you have in this one. So whatever the textbook is there, you follow that one, try to practice. I'll tell the exercise, that is a MEQ question problem is there. No, find the image of the point. Why? Because in example also, this is not asked in your textbook. So exercise you don't have here. So starting example problem is also there, one problem. So try to practice all the example and exercise problems. So image of the point we have seen in the page number 102. Okay. So if, in the exercise it is given image of the line, but in the example problem it is given they find the image of the point 1 comma 3 comma 4 in the plane. Okay. So with the help of this we can do the problem. So given problem is Find the image of the point. This is the 5 marks question. You will get compulsory image. And also in first unit, you have the foot of the perpendicular is there. So that foot of the perpendicular problem and also image of the point you will get for 5 marks questions. Okay. Find the image of the point. So if you do this image of the point, we can complete the unit 4. Next week we'll start the unit 5. We'll try to complete 5 and 6. Block 2 will be completed. Next last 2 classes we have now, 26th and 27th. So those 2 are the last class. So we'll see the block 3, that is the equation of the sphere is there. So if time is there means we go to the cone and cylinder is also there. Okay. Find the image of the point. One comma minus 1 comma 5 in the plane. X minus 2y minus 4z minus 14 equals to 0. So you will have the same like this diagram here, point P. So 1 comma minus 1 comma 5. Okay. And this is any plane you have. So here plane is 3x minus 2y minus 4z minus 14 equals 0. Here any point Q and any point here R. Okay. So for this, the procedure is the given equation of the plane is the given equation of plane is 3x minus 2y minus 4z minus 14 equals to 0. Equation 1. Here also same procedure. Before the first we have seen the example problem only like that only. Here we can take x as z as x1, y1, z1. So to find r, if you divide this by this, you will get the r midpoint. Okay. So when you equate midpoint and p, you will get the q. Okay. So that the image of the point means the image of p is here q. So we have to find the image of p, that is q value with respect to of the plane 3x minus 2y minus 4z minus 14 equals to 0. Okay, this is the concept of the problem. So after that you write the direction ratios of the normal to the plane are. So what are the direction ratios of the normal to the plane? 3 minus 2 minus 4. 3 minus 2 minus 4. Okay. So after that, let Q be the image of any point on the line. Image of point P. What is a point P? 1 comma minus 1 comma 5. Okay. In the given plane 1. In the given plane 1. Okay. So now to find R value, we have to find here P value is 1 comma minus 1 comma 5, and we are taking let Q equals to x1, y1, z1. Okay. The equations of the line PQ through P and perpendicular to. So these all steps you have to write in your examination for solving the problem. Okay. So what procedure we are following to solve the problem? We have to write that one. Perpendicular to the given plane, 1R. So here taking, so here point is this one, no, x minus 1, and what are the direction ratios? By 3 equals to y plus 1 by minus 2 equals to z plus 4 by 5. Okay, this is the line equation. We are getting PQ as a line equation. Okay, P is the point here, 1 comma minus 1 comma 5, and here whatever the plane is there, in the plane we are getting the direction ratios are 3 minus 2 minus 4. So we are writing it as, what is the point P here? 1. So x minus x1 by 3 equals to y plus 1 by minus 2 equals to z plus 4 by 5. So this is the line equation of PQ on the plane 3x minus 2y minus 4z minus 14 equals to 0. Next, here you take it as R, say, okay. So when you take the, that is a cross multiplication, what you will get? The therefore the coordinates of any point on this line are, so for Q you will get as, you do the cross multiplication, that is 3R plus 1, next minus 2R minus 1, okay, plus is there, so it will be minus 1, next 5R minus 4. Okay, so we got the coordinates of Q and we know already the coordinates of P. So we can find R, no? So R is the midpoint of the P and Q. R is the midpoint of P and Q. 3x minus 2y minus 4z minus 14 equals to 0. Okay, this is the plane equation. So now you write here the midpoint of PQ equals to the midpoint of PQ. So we can take it as R. So R is equals to 3R plus 1 plus 1 by 2 minus 2R minus 1 minus 1 by 2. So here 5R minus 1 plus by 2. Okay. So R is equals to 3R plus 2 by 2 minus 2R minus 2 by 2, 5R minus 3 by 2. Okay. When you simplify that, you will get this one. So if this point lies in the given plane, if this point lies in the given plane, 1, then, so what is our given plane? 3. 3 into 3R plus 2 by 2 minus 2 into minus 2R minus 2 by 2 minus 4 into 5R minus 3 by 2 minus 14 equals to 0. Okay. So here 3 3s are 9R plus 6 minus into minus plus 4R plus 4 minus 5 4s are 20R minus into minus plus 12, and you take for both these 3, we have denominator 2, you do the cross multiplication, that is minus 28 equals to 0. Okay, 9R plus this is means 13R, no? 13R minus 20 means you will get minus 7R, and next 4 16. Okay, 28 we have 12 you will get. So minus 12 equals to 0. We have to get one. Somewhere anything went wrong. Minus 2y, 5z minus 14 plus 6 minus 2 minus plus 4 minus 2 minus plus 4 or next minus 5 4 the 20 minus into minus 12. So actually we have to get R value as 1. So anywhere we have done mistake. Coordinates of the point 3R plus 1. What we got the equations? X minus x1 by 3 equals to y plus 1 by minus 2 equals to z minus 5 by minus 4. So equals to R means x equals to 3R plus 1 minus 2R minus 1. Next, okay, minus. So you somewhere it went wrong, you see. Minus 2R. Actually 3, 2, 4, no? So 3 minus 2 minus 4. So when you do the cross multiplication, so you you do the correction there where we have taken the point. It is x minus 1 by 3 equals to y plus 1 by minus 2 equals to z minus 5 by minus 4 equals to r. So when you do the cross multiplication, x value 3r plus 1. Next after that minus 2r minus 1 here minus 4r. This you have the correction. See minus 4r plus 5. Okay. So before problem you you verify that one. Whatever the line equation we got, this is x minus 1 by 3 equals to y plus 1 by minus 2 equals to z minus 5 by minus 4 equals to r. So you will get the coordinates of any point on this r. 3r plus 1 minus 2r minus 1 and next one is minus 4r plus 5. So here what you will get, only this will be the wrong. It is minus 4r plus 5 plus 1 by 2 means here minus 4r plus 6. So here it will be how much you will get in 2r minus into minus plus 4r. So minus into minus is plus 16r minus 24 minus 28 equals to 0. Okay. Now you see 16r plus 9r. So it will be 25r. And here what we have 24 minus 24 6 4 10. 10 means we will get here plus 4r. Actually, you have to get the r value as 1. If you get the r value as 1, if you substitute in q, then you will get the image of the point here. So somewhere calculation part has it went wrong here. So minus 4r. This is 1 minus 1. 4 minus 4r plus 5 and here it is plus 5. So you will get here plus 10. Plus 5 or not. So minus into minus plus 16r minus 40 you will get. So minus 28. Then also you are not getting 9 plus 16 means 25 plus 4 29. Okay. Then 40 minus 6 means 36. 36. Actually, you see this one, whatever here it is there, 29 plus 29r equals to 0 you'll get. Okay. So therefore you'll get 29 equals to minus 29r implies r equals to minus 1 you'll get. Okay. Somewhere the problem has gone wrong. Only the calculation part here. I'm not getting that one here. 5 plus point is 1 minus 1 5. Why you are not getting 10 fours are 40? Yeah, 4 fours plus 16 are minus 40 minus 28. So 28 is 6. This is correct only, no? Minus 3 minus 2 minus 4 equals to R we have done. That is x minus, what were the points? 1, 3, 4. So x minus 1, y plus 1, z minus 5 by minus 4. So once you check while doing the problem, this last somewhere we are not getting this one, this part. Okay. So you have to get 29 plus 29R equals to 0. So anywhere somewhere it may have gone wrong. You see that one. So you'll get the R value as minus 1. 29T minus you will get 29 minus 29. So you will get R value as plus 1. So when you substitute in Q, substitute R equals to 1 in Q. So you will get it as 3 into 1 plus 1 minus 2 into 1 minus 1 minus 4 plus 5. So the point is 3 plus 1, 4 minus 3. So 1. So the image of the point is 4 comma minus 3 comma 1. Okay, is the image of point P on the plane 3x minus 2y minus 4z minus 14 equals to 0. Okay, so the procedure I think so you have understood. So somewhere here just you do one more time the calculation part. The thing is at last you have to get the R value as 1. So when you get the R value is 1, that substitute in the Q value. So then you will get the Q is the image of point P on the plane this one. So if you understand the procedure, then you can solve the problem. Okay. So tomorrow will not tomorrow, next Sunday we'll see the block 3. So in block that is the unit 5. In block 2, so even the definitions or formulas, you try to remember them. Why? Because definitions and also formulas you will get for the objective type questions. In the math the following you will get, and also in the fill in the blanks you will get, or else in the multiple choice questions. Okay, so try to see all the whatever the points are given you in your textbook, rather than the problems you try to miss with what is the condition of perpendicularity, what is the condition of parallelism, and also what is the condition to find the angle between the two planes or lines, or one line and one plane. So like these formulas are there, no, these all you will get in the objective type questions. Okay, and small problems means direct problem when you substitute in the formula, that also they will ask for the multiple choice questions. Okay, so this time compulsory you will have the objective type questions, and that are the 20 marks you will have. So 10 marks you will have the multiple choice questions, and 5 marks you will have the math the following, and 5 marks you will have the fill in the blanks. Okay, so try to practice all those. And next is unit 5. We have the concept of skew lines and shortest line segment between two skew lines. Okay, so here just the concept of what is the skew lines is whenever you will take the two lines which are not intersecting. Okay, and they are so depending on that skew lines, we have the shortest line segment. So in unit 4 and unit 5, you have the chance of getting 2 10 marks questions. So unit 4, you will have the finding the coplanarity or intersection or point of intersection, and also containing the line. Okay, and shortest distance here is the concept of the projection of the line with the two direction ratios. Here two line equations will be there. They are in the form of the symmetrical form. If you see page number 129, so in that you have length and equations of the shortest line segment. So two line equations will be there. So in that here direction cosines are L1, M1, N1, L2, M2, N2. So with the help of that, you have to find the shortest line segment, distance between the two given lines. It is called as the shortest line segment, SD we can tell shortcut. That is first part. So for 5 marks means only they will ask the finding the shortest distance. If he is asking for 10 marks question, then they will ask the equations also. Okay, the means equations means same formula. For coplanarity we have done no, x minus x1, y minus y1, z minus z1, l1, m1, n1, and here lmn. So lmn are the values you will get when you will find the whatever the shortest distance is there you will get the lmn values. If you put them in the determinant and if you equate it to 0, then you will get the equation of the plane. Okay, so this will be the 10 marks question if shortest distance and plane is asking. Okay, so if only shortest distance means 5 marks question. So for this solving shortest distance also you have the 2 methods are there. So even actually 3 methods are there. So first 2 methods are somewhat easy one. So easily you can solve with the help of the 2 methods. But with if you solve with the 3 methods, you will get the same answer, shortest distance and also the equation. Okay. So first method is, in this we'll use all the formulas. So how we have done for coplanarity. For the line of projection, you will have the formula as L into x2 minus x1 plus m into n2, that is y2 minus y1 plus n into z2 minus z1. Then when you substitute lmn values and x1, y1, z1 and y2, that is x2, y2, z2 values, you will get one value. That value is called as the length of the shortest distance. Okay. So after for finding the equation, that is a mod of whatever the determinant is there. If you substitute there, you will get the equation of the plane. Okay. So another one is whatever the line equations are there. No. So for that line equations, we'll take the two values as r1 and r2. Okay. So then if you do the cross multiplication, so for finding the point of intersection, we have done no same that procedure. First line equation equals to r1, second line equation equals to r2. So when you simplify that, you will get x, y, z values. And if you find the distance between those 2 points P and P1, so whatever the answer you are getting r1 and r2, if you substitute in the point, you will get the 2 points. Okay. So if you do the subtraction of those 2 points, and if you substitute in the, that is manaki, we have no distance between the 2 points formula, under root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So with the help of that p and p dash, if you substitute values, you will get the length of the shortest distance. For the equation is, you have to substitute the that is x1, y1, z1 values and the direction ratio, then you will get the equation of the plane. So that is the second method. And third method means you have to do with the help of the formulas only. Okay. So almost third method will not consider, or else you can take that one also. If it is easy means you can take the third method. So 1 and 2 are regularly used for solving the problems. Okay. So this is the concept you have in unit 5. So the main thing is only finding the length of the shortest distance. And one more is there, that is find the length of the perpendicular. The length of the perpendicular from a point to the line. So that is, the point is alpha comma beta comma gamma, and the line is x minus x1, y minus y1, z minus z1. So for this also you have formula. If you substitute these values in the formula, you will get the length of the perpendicular. So intersection of 3 planes is there. So this problem is the 5 marks question. 138 page number you have. Intersection of the 3 planes, but this is the compulsory question. 5 marks, one problem is the compulsory one. If you see page number 140, examine the nature of intersection of the following set of planes. Okay. So here 3 different types of questions are given. The procedure is the same one. You have to find delta, delta 1, delta 2, delta 3. So first thing is, if you are getting the delta as 0, and delta 1, delta 2, delta 3 values are not equals to 0. Delta, delta 1 means I will do for the Kramer's rule. Determinant will be there, no? That type of problem. So if you are getting the, for forming the planes a prism, the condition is that delta value should be 0 and other 3 delta values should be not equals to 0. So then only the given 3 planes form a prism. Okay. And if it is the second condition, hello. Okay, whatever the problems are there in the nature of intersection, we'll see the next class. Okay, bye students.